Hello. In two of our last videos, we have already focused on ground penetration radar with microwaves. Today, we will see an archaeological application of GPR. In this video, archaeological studies on one of the earliest features built by English settlers in the United States is shown. That is the Palisade Wall from 1608 in the James Fort in Jamestown, Virginia. We will see the physical location and the appearance of this early defensive structure. And we will see how GPR can be used to detect archaeological features before they are excavated. Two different frequency instruments are used, and they are used in normal mode and in cross-polarization mode. In the latter method, two separate antennas are used for transmit and receive. The receiving antenna is adjusted such that it detects only such waves which have an electrical field which is perpendicular to the transmitted one. That means that only such structures in the ground are detected which, due to their shape, cause a polarization conversion. This, in some cases, can be advantageous to suppress unwanted signals. Let's look to the video.
Hi, I'm Dave Givens, the Director of Archaeology here at the Jamestown Rediscovery Project, and I'm standing down in a test unit that we had filled in and lined with sandbags a number of years ago. So this was an area where we talked to the public about the 1608 extension to James Fort. Now right here below me is the palisade representing that line. It came out of the north bulwark to the west of me here, and then east over here to a blockhouse, which has since been excavated and filled back in. Now you'll see around the bottom, we put down geotextile fabric and protect it, but often we'll leave an area, and we don't dig everything we find, we'll leave it open. And in this case, it's the subject of this week's Dig Deeper video. Now what we're doing here with this, and I'd love to backfill this and preserve this for future archaeologists, is we want to run high frequency GPR on this. Now my colleague Peter Leach from GSSI, who makes the equipment that we use here at Jamestown, has flown in to join us here, and we have this theory that we can use the GPR in different methods. Now the 1608 Palisade, like I said, was constructed as an extension onto the original 1607 James Fort, and was built by using a tool actually called a scupper, a very narrow hoe, and they dug a flat bottom straight sided trench, put the logs upright in that trench, and then backfilled them. So what we see archaeologically is the remains of the trench, mixed fill, mixed aggregate clay, horizon soils, and then stains of posts that almost look like fried eggs as they go along and then terminate over here next to the building. So our hopes today are that we can push the science forward of ground penetrating radar and actually be able to see not only the feature, because we're confident we can do that, but actually see if we can see different layers and the structure of it. So the work we're conducting is typifies the ongoing relationship between GSSI and Jamestown Rediscovery as research, right? So it's not always about digging things up. Sometimes it's about finding out about the past through science, right? Archaeology is a science. And so Peter's going to explain how we conduct that science and how GPR can push that research forward.
I'm standing on a surface, an excavation surface here, where we can see the top of the 1608 Palisade feature. And so we decided to use a high frequency GPR antenna, which is typically restricted only to use in concrete. And it's very high resolution, but the trade-off with radar antennas is that you get real high resolution. You can see small objects, small soil changes, but you don't get particularly good depth penetration. We expect maybe a foot and a half here max. But the idea was we wanted to use a high frequency radar antenna to scan across the Palisade feature and see if we could discern, first of all, discern the feature itself from the natural surrounding stratigraphy, the soil matrix, and to see if we could image internal characteristics of the Palisade feature for use in other situations where the Palisade may not actually have been excavated or exposed, and we may be able to view it from the surface down and not have to excavate. So we used two different antennas in two different configurations for this. First, we used a Structure Scan Mini XT GPR. That's a self-contained unit at 2700 megahertz. That's the highest frequency antenna that we make. And we actually attached a palm antenna to that, which is more archaeologically sized. It fits in your hand, which is excellent for the tight space constraints inside of an excavation unit. And so we collected data in a configuration called normal polarization, and it's the way that data are usually collected. We collected a grid at 1-inch intervals across a 7-foot expanse along a very well surveyed grid so that we can control the line spacing, we can collect straight lines, we can do this very scientifically. What we next did was we used a technique called cross polarization, where we turned the antenna 90 degrees to its normal path of travel and still collected lines in the same direction. And that's never been done for archaeological work, to my knowledge. Usually it's not done anywhere except, again, in concrete environments where you're trying to find rebar and conduit. The idea being that in normal polarization, the energy leaving the GPR antenna spreads out with depth at approximately a 90-degree angle front to back. And so that generates the classic hyperbolic targets that you see in GPR data, these upside down U's, looks like a fish on a fish finder. And that gives you your normal looking data. But to me, that spreading with depth has the potential to distort soil layers and other targets at greater depths because the wave front is spreading out so far. And so in cross polarization mode, we're going in the forward direction. The cone of penetration, the wave front, is really only spreading out at a 45-degree angle. And so the effects of more distant targets and layers is not as, it doesn't have as much of an impact on the radar data. And to me, I hypothesize that that will actually focus the radar data and give us a better representation of soil layering and stratigraphy. And so we collected those data with the Mini XT in normal polarization and cross polarization. And then we decided that we wanted to use a lower frequency antenna. So we went from 2300 megahertz to 1600 megahertz to try to get deeper penetration. Of course, that antenna has lower resolution than the other one, but that's also part of the experiment, because a lot of times in all walks of life, we find the closer you look at something, the uglier it gets, most of the time. With GPR, it's the same. So the higher the resolution you have, the more stuff you're picking up. but that could be archaeological materials that we're interested in, but it also is soil clutter, wormholes, rootlets, any type of coarse clast in the matrix. And so we used that antenna in normal polarization, and we cross-polarized it. And we collected exactly the same grid lines, exactly the same length. So now we can compare the two directly. And the idea now is that we have to go and post-process the data, much like a professional photographer will use Photoshop to enhance and improve their photographs. We use a software that my company makes called Radan 7, and it's like Photoshop for GPR in the sense that we can clean up and optimize GPR data, take away some of the noise, drop down the highs, bring up the lows, and improve the overall data. The other thing that we can do is, since we collected data on a grid, we know where every single data collection point was in space. We can funnel that into our Radan 7 software. We can construct a 3D cube of the survey area that we can then slice down through, like we were using a digital trowel to slice soil layers away. And what that allows us to do is, with profiles, we can look at cross sections, like looking at the wall of an excavation. But with the time slices, the 3D cube, we can slice down through the ground and actually see the geometry, the shape of targets and features. And that gives us one more level of interpretive information that we can use in other situations when we're not looking directly at the feature with our eyes. Perhaps we're a foot above on the modern ground surface. And so we can use all of this information to build a more holistic interpretation of the feature and the behavior of the radar in this archaeological context. So here we have our SIR 4000 control unit, and this is what we use to collect the 1600 megahertz data that I mentioned, both cross-polarized and normal polarized. And what we see here on the screen is a typical, a representative profile of the GPR data from the 1608 Palisade survey. What we have here is we're looking at a vertical profile. This is very similar to looking at the wall of a backhoe trench or looking at the vertical wall of an excavation, an archaeological excavation. So we have depth on the side, and we have distance along the top. Both of them are in feet. And so first, when you first look at GPR data, you might be thinking that it's really just a photograph of a pile of dead zebras or something. It is not. There are actual data in here. And so what we have is you can see right in the center here between the 1 foot and 3 foot marks, there's a very bright area here. And then on the sides, it's actually quite weak, really low amplitude. And so what we have is this between 1 and 3 feet is actually the 1608 Palisade, like in cross-section view, like we had excavated, cut a line across it, and we're looking at it from the side. And so this is the Palisade, and you might have already figured out that over here and over here is just natural, undisturbed subsoil. And so this is the soil matrix that is that's natural soil, and here is the cut from the trench. And so we have the sides of the trench here and here, and then inside we have a lot of other layers. We have a lot of these hyperbolic targets that suggest that there's maybe some targets in there, like rocks. Perhaps we've gone over the decayed remnants of one of the original posts that was part of the construction of the Palisade. And then we have, as we get deeper into the ground, we start to get an area that we call attenuated. And so this is really staticky, it's really noisy, and it's telling me that we're starting to max out the depth of the antenna in this location, because an antenna will eventually bottom out. There will not be enough energy left to penetrate any deeper. And so this is good. Actually, I want to see this on the bottom of a GPR profile because it tells me, without a doubt, that I penetrated as deep as I possibly could into the subsurface. and any additional depth information would have just been all noise, and it wouldn't have been really worth collecting. But I'm very, very satisfied with these data, because what we're seeing is that the Palisade shows up extremely well. And the best part is, and one of the most important things in GPR data is contrast. Is something anomalous compared to the undisturbed soil that does not have any Palisade features in it? And in this case, the 1608 Palisade is very, very apparent. It's very, very obvious. It contrasts very sharply with the undisturbed subsoil. And so that is a really good result going forward, because we know now that GPR behaves quite well in this environment. And going forward, we can use this as a potentially a diagnostic signature to find other sections of this Palisade that have not been excavated before, and then we can map it on the ground without having to do excavation.
I'm certainly excited about what we found out so far with just the 2D data and just running it across. And I'd really like to see this applied to other features that we've had out here. And going forward, I think we'll really be trying it out.
Yeah, for sure. There's so much research potential out here. I mean, radar, we've already seen in our other research that radar works very, very well out here, whether it's lower frequency or high frequency. We've had a lot of success, and I see more in the future. And I think that we're moving towards a digital trowel kind of method, where we can use GPR to really learn a lot about features without necessarily having to completely excavate them. And it really is in support of a preservation in place model, where we do need to preserve archaeology for the future. And one of the ways that even if we are going to excavate it, doing GPR will give us a digital archive that can supplement and augment the traditional archaeological methods. So this has been really great, and I think that when we start, we start looking at the data and comparing it to other things, it's going to be extraordinary.
Yeah. So our next series on this, we'll process the data and let you all know what we found. So stay tuned, and thanks for watching our show, guys.
I hope that this video was of interest to you. Please don't forget to share it. That's it for today. See you next time. Goodbye.